Alrighty, Algebra 2, Lecture 113, 114, OAS A2A17. The student will evaluate arithmetic series, determine the number of terms in a series, and evaluate arithmetic series that are written in sigma notation. Okay, I want to start out by just defining what a series is. The last couple of days we've dealt with sequences, and a sequence is just a row of numbers that have commas in between them. And there's a distinct pattern to that. In an arithmetic series, the pattern is that consecutive terms have a constant difference. So that's what we were talking about when we talk about series. We're going to take that sequence and we're going to add all the terms together. So that's what a series means. We're going to take the terms of a sequence and add them together. And this is going to be arithmetic, just like we did for the last couple of days. Instead of dealing with arithmetic sequences, we're going to be dealing with arithmetic series. We're going to add the terms together. We're going to determine the number of terms in a series and evaluate an arithmetic series written in sigma notation, and I'll show you what that is here in just a second. And my board isn't responding, so let's see if I can get it to respond. Yay! Okay. Here we go. A series, excuse me, a series is the sum of the terms of a sequence. So you have a sequence of numbers with a bunch of commas in between them. And if you add those numbers together, we call that a series. And here's a formula that will do that for you if you know that the series is arithmetic. That means that consecutive terms, the terms right next to each other, all have a common difference. If you take the one on the right and subtract the one on the left like we did for the last couple of days, you get the same number every time. That's an arithmetic series, and this formula will add all the terms for you. Now, if there's just a few terms in the series, like if there's just 4 or 5 terms, you can just add them up with a calculator. But if there are 50 or 60 terms or 500 terms, this is much quicker, okay? So what we're going to do is put the sum of n terms, that's the number of terms right there, is equal to the number of terms divided by 2 times the quantity. First term, a sub 1, is the first term. A sub n is the last term in the sequence. Okay? It's going to be a finite sequence. It'll have a beginning and an end. And the number of terms is n. So this is the sum of the number of terms is the number of terms divided by 2 times the quantity, first term times the last term. Okay. So if I was going to evaluate the related arithmetic series, this is a sequence. It doesn't say plus sign, but the related arithmetic series, you don't have to write this down, but here's what the series is. Whoops, it's supposed to be a 36. There we go. There's my arithmetic series. I'm just going to add the terms of this sequence. And I'm going to use the formula just to show you how it works, okay? Our formula is the sum is equal to n over 2 times quantity a sub 1 plus a sub n. So we've got the sum of n terms is equal to n over 2 times the quantity a sub 1, the first term, plus a sub n, the last term. And here we go. I'm going to say, well, the sum of, how many terms have we got? 1, 2, 3, 4, 5. The sum of 5 terms will equal 5 over 2, that's the number of terms, times the quantity, the first term, which is 18, plus the last term, which is 54. Now we can do this with a calculator. What I'm going to do is just add them together and then multiply them by 5, multiply this by 5, and then divide by 2. I mean, that's not how you have to do it, but that's how I'm going to do it. So that 18 plus 54 equals, times 5 equal divided by 2 equals. I get 180. 180. And no matter how you do it, you should get 180 if you don't break any of the rules of arithmetic. That's what we'll get if we add up these numbers. Now again, as I said, you could get 180 just as quick probably just by adding 18 plus 27 plus 36, et cetera, in a calculator, because there are only 5 terms. But if there were 100 terms, it'd be much quicker just put the first term, the last term, and the number of terms into this formula and let the formula do the walking. Okay? So let's take a look at another example. Here's one. Here I have 1, 2, 3, 4, comma, dot, dot, dot. That means continue the pattern until we get to 98, 99, 100, and we stop. So there are 100 terms in this. We're going to 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 all the way to 100 and stop. And our instructions are evaluate the related arithmetic series. So the related series is going to be 1 plus 2 plus 3 plus 4 plus dot, 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 plus 98 plus 99 plus 100. And that would take a little while to do on a calculator. You could do it, but it'd be much quicker just to use our sum of a series formula, which is the sum of n terms is equal to n over 2, where n is the number of terms, times the quantity of the first term plus the last term in the sequence. So I'm just going to add these up. I can see that there are going to be 100 terms. 1 plus 2 plus 3 plus 4 plus 5, all the way to 100. There are going to be 100 terms. So I will say the sum of 100 terms is 100 over 2. That's the number of terms right there. First term would be 1, plus the last term would be 100. That will give me 101 times 50. So I'm going to do that. Sum of 100 terms. This is 50 times 101. So we'll do that real quick. And that gives me 5,050. So if I add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, et cetera, et cetera, et cetera, you'll get 5,050. So what have we done? We use the formula for an arithmetic series. This will only work if the series is arithmetic, to add the terms of a series. And the student will evaluate arithmetic series. That's what we just did. Determine the number of terms in the series. I'm sure we'll get to that here in a little bit. And then use sigma notation. So let's take a look at what else we have here. Evaluate the series described here. Well, I have the first term, I have the last term, and I have the number of terms. Well, that's all I need for my formula. I need the first term, the last term, and the number of terms. So if they say evaluate the series, and they give us the first term, the last term, and the number of terms, we can just plug these straight in to our formula. The sum of n terms is equal to the number of terms over 2 times the quantity, the first term plus the last term. And here I can see that I'm going to have 12 terms. So I'm going to say, well, that's the sum of 12 terms. N is the number of terms. Is equal to 12 over 2, which I could just call that 6. First term is 13 plus the last term is 35. And that will give me, what is that, 48 times 6? Whatever that is. I wouldn't normally do that in my head, but it's early and I make lots of mistakes. I get 288, I might as well check that and say, yay! I highlighted my answers today. So the sum of these 12 terms would be whatever I just said, 288. We had the series described to us. If the series has the first term of 13, a last term of 35, and there are 12 terms in the series, and it's definitely arithmetic. It has to be arithmetic or this won't work. Okay, based on what we've done for the last couple days, arithmetic. So there we go. Let's take a look at another one. Here we're given the first term, we're not given the last term, but we are given the number of terms. So if we're given, what this says right here is if you're given some information but you don't have first term, last term, and number of terms, but you are given the common difference, use the explicit formula that we did yesterday and the day before in our sequences to find the term that we're missing. In this case, we're given the first term, we know the number of terms, so we need to know what the last term is. So I'm going to use my explicit formula from a sequence. A sub n is equal to a sub 1 plus the quantity n minus 1 t, which is the common difference. I'm going to plug in everything I know, and the only thing I won't know is the last term. And then this will tell me what the last term is, and then I can use this formula that we just did. We need the first term, the last term, and the number of terms. We have the first term, we have the number of terms, but not the last term. So I'm going to use the explicit formula, determine what the last term is, and then use our series formula. That's the plan. So here we go. Let's see if I can do it. A sub n, that'll be the last term in the series, is equal to the first term, that's 33, it tells us that, plus n minus 1, well it tells us n is 11, it tells us that, so 11 minus 1, that's 10, times d, which is 10. So my last term in this series is 33, plus what is that, 100? 10 times 10 is 100. So my last term is 133. Now I can use my sum of an arithmetic series. N over 2, first term, which was given to me, plus last term, which I just found. Here's my last term right here. So here we go. Let's see if I can do this correctly. The sum of, how many terms do I have? 11? The sum of 11 terms is the number of terms over 2, 11 over 2. The first term is 33, plus the last term is 133. And I'm going to add these together, multiply by 11 and divide by 2. Let's see what I get. And hopefully I haven't messed it up. I do make mistakes, as you well know. I'll try not to, though. Times 11 divided by 2. I get 913. So that's the sum of this series that's described. The series has a first term of 33. The series has a common difference of 10. That means if you take any two terms in the series and take the one on the right and subtract the one on the left, two consecutive terms, the difference of those would always be 10. And there are 11 terms. And those should add up to 913 if I haven't made a mistake. Let me see. Here, yay, I got it right. So hopefully that made sense. And here we want to determine the number of terms in an arithmetic series. And that's, again, one of our objectives here. The student will evaluate the series, determine the number of terms in the series, and evaluate written in sigma notation. So we're going to determine the number of terms just using our, since I know it's an arithmetic series, I'm going to say, well, the sum of n terms is n over 2 times the first term plus the last term, the quantity, the first term plus the last term. And I want to determine the number of terms. So that will be n. So I will know all of these. I'll know this one, and this one. And the only one I won't know is n, and I'll just use algebra 1 to solve it once I plug everything in. So the sum of the terms is negative 930. I'm just substituting what I know in. The number of terms I don't know. That's what I'm looking for. Determine the number of terms. So I don't know. N over 2. Don't know. I do know the first term is negative 20. I do know the last term, there it is, negative 104. I'm going to do just a little bit of arithmetic here. and simplify this right here. This will be negative 124 divided by 2, and that is negative 62, I believe. Let me see. Yep. So this will simplify. This divided by 2 is negative 62, so I've got negative 930 is equal to negative 62n. If I go this plus this, add them together, and then divide by 2, that'll give me negative 62. And I'm going to divide both sides by negative 62 now. And this will solve, hopefully solve, if I haven't made a mistake, for the number of terms in this particular series. Where'd my calculator go? 930 divided by 62, negative over negative will be positive, so I can ignore the minus signs. 930 divided by 62. 15. So hopefully, if I haven't made a mistake, there are 15 terms. Scroll that a little bit so you can see that. And let's see if I've gotten it right. Yay! Alrighty. Okie dokie. So that's how we find the number of terms in the sequence. You just plug in everything that you do know and solve for the one you don't know. And the last thing we're going to talk about is sigma notation. And that's this thing right here. It looks scary. You'll see it a lot in calculus and whatnot. You'll use it a lot, but it's simple. Once you understand what the symbol means. When you see this, it just means you're going to add up some stuff. You're going to be adding some stuff. And that's what we do in a series. We add the terms of an arithmetic series. So what we have here is going to be an arithmetic series. And I'm going to show you what this means specifically, but I don't want you to do this on your papers. I'm just going to show you what this means, and then I'll show you how to do it, how to add up all your terms very, very quickly. Because what do we need to add up our terms? Well, we need the first term, the last term, and the number of terms. Well, when I see this, here's the number of terms right here. I have 20 terms. I can find the first term and the last term very easily, because what this means is we're going to add up this. If we let n equal 1, and then we let n equal 2, and then we let n equal 3, and then we let n equal 4, and we're going to do that until we get to n equals 20, and we're going to generate a bunch of numbers. Now again, I'm saying you don't have to do this part. I'm just showing you what this means. If you were going to read this with word, you would say, this is the sum, as n goes from 1 to 20, of n minus 8. You could say it that way, or you could say the sum of n minus 8 as n goes from 1 to 20. Here's what that means. We plug in a 1, we get 9 times 1 is 9, minus 8 is 1. Plus, now I'm going to plug in a 2. N's going to go from 1 to 20, just the integers, 1, 2, 3, 4, 5, the counting numbers. Okay, so I'm going to plug in a 2, that's 18 minus 8 is 10. I'm going to plug in a 3 now, I'm going to go from 1 to 20. That's 27 minus 8, that's 19. I'm going to plug in a 4, 9 times 4 is 36, minus 8 is 28. I'm going to plug in a 5, 9 times 5 is 45, minus 8 is 37, if I'm doing my arithmetic right. And I'm going to keep going until I get to 20. I plugged in a 1, I plugged in a 2, and I got this, plugged in 3, plugged in 4, plugged in 5, and I'll do that until I get to 20 and then add all those terms up. That's what this means. But we have a formula that will do all of this for us. We don't have to do this part. That's just what this means. To add them up quickly, all we need is the number of terms. That's this right here. The number of terms times the first term. That's what we get when we plug in a 1. And the last term, which is what we'll get when we plug in this number. In this case, it's a 20. But it won't always be a 20, but in this case, it will be. So I'm going to say this will be the sum of the number of terms divided by 2. So that's 20 divided by 2. I could just call it 10. The first term will be, well, what do I get if I plug in a 1? 9 times 1 minus 8 is 1. There's my first term. 1 plus the last term. What do I get if I plug in 20? That's 180 minus 8. That's 172, I believe. I'm going to do that with a calculator just to make sure, because it's early in the morning and I'm easily confused. 20 times 9 minus 8. 172, yay. Now I'm just going to do this. This is 173 times 10, I believe. And that's 1730, yeah. So if I add up all these numbers, 1 plus 10 plus 19 plus 28 plus, this is an arithmetic series that's generated by this sigma notation. And if I plugged in all 1 through 20, I'd have 20 terms here, but I can add them all up using my sum of an arithmetic